The setup is always the fun part. I got some popcorn today. But, yeah, I don't really have anything to do today. So, that means instead of interact with people, why don't I learn programming? The normal things you do. It says it's a 12-week course. Can we do it in a month? I honestly doubt that. It's probably going to be pretty hard. But, we'll see. Anyway, everything pop up first. Hello. Hi. Sup. Let me just, turn those off for now before I start fiddle-daddling too much. Turn on Unity Learn. Get some stuff sorted. Just want to get my, all my stuff together first. Oops. I'm writing my login when I use Google. Badam. Badoof. Okay. Was it this one? Yeah, it was this one. So, let me also get my Word document up for this. Game dev knowledge. The document. I'll probably need to actually write down a lot for this. I got the scripting stuff done. I have the skills section. We're just going to enter that and make a programming section. Oops, not a heading 2. Well, not a heading 1. I want a heading 2. Okay, so just to pop that up there. Alright, why isn't it coming up? Oh, I put it on Visual Studio, that's why. I should probably leave it on that, I guess. Gonna turn all that stuff on now. It's gonna take forever to load anyway. But, so, our next step is Junior Programmer. Gives us 3,000 experience. Not that it really matters, but that's what it does. This one says, welcome to Junior Programmer, designed for anyone interested in learning to code or obtaining an entry-level Unity role. This pathway assumes a basic knowledge of Unity and has no math prerequisites. Junior Programmer prepares you to get Unity certified so that you can demonstrate your job readiness to employees. So how much programming actually needs math? I'm not always sure about that stuff. Like, you need to know some, like, division subtraction, multiplication stuff for variables, I would assume. But I feel like a lot of that stuff you could just Google also. So how many, do you need to like know formulas for certain things and later programming skills? I'm just not sure. So we have the pathway, and each mission is a branch of different things to do. I think the assignments are like... I think the assignments are maybe different tasks. I don't know how to say it. I know what it means. I know what I mean. Well, whatever. We'll get into it. Okay, so yeah. All of the missions can be several projects at once. Oh, good. It's going to start with player control. That's kind of what I was looking for the most, because I'm curious to see how it works, and I think it'd be cool to learn that at least right away. So this should be... I think this might be fun. I do wonder if this is also gonna have us, like, end with make your own game. Even if it's like 10 minutes or something. This mission will take you approximately 14 hours to complete. Take it at your own pace. You'll receive EXP at each step of the way. Connect with the Unity community as you learn, and check the live calendar for follow-along practice sessions with Unity established creators. When you finish the mission, you'll get the mission badge for your profile portfolio. Okay. Okay, so doing all the player control stuff is going to take the longest. And then they have the introduction to project and management stuff. Is probably going to be a quiz thing. And this is just going to be the first of many. So the first one is going to be 16 hours long, so even if I did this constantly, it would at least take 2 days. Create with Code 1. Programming Basics. Like I'm back in class. Never taught us this. I'm gonna take even longer because I'm snacking on popcorn. Well, I should probably actually look at the videos for this stuff, just in case they actually say important things, right? Did I still have... I probably want to bring up my volume mixer, just because this stuff blares in your eardrums. I feel like I'm gonna sneeze. Maybe I'm not. Well, I'll turn this off for now while I listen to this.
Welcome to this official course from Unity, where you will learn to create with code. My name's Carl, and I'll be your instructor, teaching, guiding, and challenging you every step of the way. I studied computer science and game development, and have been helping students create with technology for almost 10 years. And I am so excited to help you learn to code and achieve your goals. So what is the goal of this course? Well, it's pretty straightforward. It's for you to learn to code and create with Unity. That means it's not a history of programming course. It's not a theoretical course. It's a practical course to give you the foundation you need to be able to program whatever you want with Unity. With Unity, you can build applications for mobile, like iOS and Android, platforms like Windows and Mac, consoles like PlayStation and Xbox, VR and AR devices like Oculus and Google Cardboard, and a lot more. Think about it. Every app on your phone, every program on your computer, all the technology you interact with on a daily basis was made with code. And if you learn to create with code, you can help to build that technology instead of just using it. I'll be teaching you how to code in C#, one of the most popular and powerful programming languages in the world. So, as you are learning to create with code, you'll be doing so with Unity and C#, both in-demand, industry-standard skill sets. Now let's get into the details. How are you going to learn all of this? Throughout the course, we'll create 5 distinct prototypes together, coding every single line of C# from scratch. In each one of these prototypes, you'll learn critical new concepts, expanding and reinforcing your skill set with each new feature you add. After completing each prototype, I'll present you with a skill testing programming challenge and quiz where you can prove that you're ready to move on. And finally, throughout the course, you will also work on your own personal project that is completely and uniquely your own. You'll have lab time to come up with a design and concept for your project, plan it out, and build it. So by the end of this course, not only will you theoretically know how to create whatever you want with code, you'll have already done it. At the end of this course, you'll also be ready to take on the Unity Certified User Programmer exam. That's Unity's official stamp of approval, certifying that you know what you're doing. In this course, you will combine the knowledge of coding in C# with building in Unity, and in doing so, you will be able to create interactive, dynamic digital experiences. You can use these skills for game development, animation, storytelling, architecture, engineering, you name it. The sky's the limit. So let's start creating.
I wonder if that exam is something that you can take online. Or if it's gonna say, you have to go to a city that actually offers the exam. Or whatever. Or you have to pay $300 to take this exam. Unless it's just something that Unity offers. Not that I would know what that would mean. My popcorn is dwindling. By the time we reach the hour mark, it should be gone, you would think. No, I actually probably chad down on it too much. Watch, then do. Oh, we're gonna have a lot of videos for this one. Install Unity software is the next tutorial. Well, anyway.
Before you get started working on the course, there's something really important I have to tell you about how you should take this course. Even though it's just one little piece of advice I'm sharing here, it's so important that we made this entire video to tell you about it. So without further ado, here are the 3 most important words you'll need to know to succeed in this course. Watch, then do. This course is made up of a ton of videos that you will watch where I'm showing you how to do cool stuff in Unity. But while the video's playing, just watch it. Then, after the video ends, you'll have the opportunity to do it yourself. Watch, then do. If you try to do what I'm doing while you're watching it, it'll be very difficult for 2 reasons. It'll be incredibly frustrating for you. You'll have to keep switching back and forth between the video and your project, not knowing when to pause, having to rewind all the time, being confused because you missed something, and basically just being super annoyed overall. And 2, in trying to do what I'm doing while I'm doing it, you won't actually process or retain any information since you'll be furiously clicking around where I click without understanding the broader context. After every video, there are step-by-step instructions outlining exactly what you need to do. So watch, then do. I'm telling you, in these early lessons especially, it's going to be tempting to ignore this advice. But you have to trust me on this. You'll get so much more out of this course and enjoy it so much more if you watch, then do. 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 Okay? I'm pretty sure you get the idea, so let's do it.
Well, I watched it, but I'm not doing it. So is this one going to be video heavy? I wonder. Maybe it's easier to explain verbally, though. I mean, I know they have transcript stuff, too. Popcorn is gone, by the way. I guess if this is video heavy, then I can just kind of, engaging instructor, sure. Then I can just kind of, you know, go through it. Install Unity software. Can I just skip over this? Before you get me in, download and install Unity Hub, install a new version of Unity. I mean, I guess you can technically do this in any order you want, but they want you to use the Unity Essential thing first. It's just weird to me that they have this part in here. Or I feel like they could have programmed it, so if you had whatever variable filled, it would make you not have this in your learning exam. So I'll probably just skip over this. I do need to launch the Unity Hub, because I did not do that. So we did that, we got it installed. I'm just gonna skim over this just in case they say, download this thing instead, or something. We should be fine with Visual Studio stuff. I already was using that. We used it in Essentials. That's all fine. Why are you flashing, Unity Hub? You okay? You okay there, Unity Hub? It's doing stuff. Okay. Seems all fine. Clear instructions. PP is safe, sound, functioning. Clear instructions. I understood. Okay, so let's get into the nitty gritty. The juice, if you would. The juice of our project. The thick, succulent juice. That's kind of gross. There's no juice in your project, right? Like that's a little weird. The juice of our project. Say that again. The juice of our project. There you go. You said it right. Anyway, an introductory video for Unit 1, where you will learn to implement player control. Okay, this does have quizzes, too. So, take notes as needed. I guess I will stop my music again. Just play it. I'm gonna keep muting while this is happening. If I think I need to take notes on something, I might like pause it, but well, they say that watch and do things, so I guess I'll just mute, watch the whole video, and then I can just replay parts if I think I need to take notes on anything. I don't know what they'll cover right away in the videos, or if this will just be like, this is an introduction into this unit, and then the next video is what you're actually supposed to do. But we'll figure that out. So I'm just gonna mute now, and we'll see what happens.
Welcome to the very first unit of this course, where you will begin your journey creating with code. In this unit, we will create a driving simulator prototype where the user can steer a vehicle down a road to avoid obstacles in its path, or crash into them if that's more their liking. As you create this prototype, you will learn the programming fundamentals to implement player control. That is giving the player the ability to control an object in the world you've created. To accomplish this, you'll have to take some input from the player. Maybe they're pressing the arrow keys, using the mouse or a joystick, and translate that into some action in the 3D environment. I probably don't have to explain to you how important player control is. Pretty much every game or interactive experience ever made gives the player control over something in the environment. Otherwise, the player wouldn't have much to do. So whether you're floating a balloon up and down in the air from a side view, moving a character side to side from a top-down view, or rolling a ball around from a third-person view, all of these draw on the same foundational programming techniques. So you'll be able to take this element of player control and apply it to your own projects in all kinds of interesting ways. So let's start creating.
Well, right away I find it interesting that they don't mention first-person stuff in that. That's interesting. So I'm curious to see where this will go. But yeah, I was right. It was just, this is what we're doing. But it seems like this will have a video right away. So, is this a video also? Yeah. Overview video. Full video. It doesn't say how long that one is, but I'll just read this stuff really quick. In this lesson, you will create your very first game project in Unity Hub. You will choose a position for position a vehicle for the player to drive and an obstacle for them to hit or avoid. You will also set up a camera for the player to see through, giving them a perfect view of the scene. Throughout this process, you will learn to navigate the Unity editor and grow comfortable moving around in 3D space. Lastly, you will customize your own window layout for the Unity editor. You will have a vehicle and obstacle positioned on the road and the camera set up perfectly behind the vehicle. You will also have a new custom Unity layout perfectly optimized for editing. Okay, so this is just getting set up. This might have redundant information then for stuff we already know, but I'll go through all of them.
We are about to begin working on our very first prototype, where we'll make a vehicle that can drive down the road. To do this, we will create a project for the first time, use the Unity interface for the first time, import assets for the first time, and navigate the 3D environment for the first time. That's a lot of firsts, but don't worry. We're going to take things one step at a time. By the end of this lesson, you will have your first prototype with a vehicle and obstacle set up on the road. As you know, Unity is a powerful professional program with a ton of functionality. So when you open it for the first time, you may feel a little overwhelmed by all of the windows and buttons and icons, but with a little time and practice, you'll be able to move around this interface with your eyes closed. After you're familiar with the layout, one of the most important skills we'll work on is navigating and positioning objects in the scene view. The scene view is the interactive environment where you can design your world in 3 dimensions. When you put your vehicle in the scene, for example, you can move it side to side on the x-axis, up and down on the y-axis, or forward and back on the z-axis. You can also rotate objects around each one of these axes, scale them on each of these axes. You can even view your object on each axis. You can think of Scene View as the movie set for your project, where you can see all the behind the scenes stuff that the audience won't necessarily see. And just like a movie set, you have a camera in your scene that you can position to show the player exactly what you want. In Unity, what you can see through the camera is called the game view, since it's the view that the player will have during the game. So for this prototype, we wouldn't want the camera here or here, so we'll position it behind and above the vehicle, giving the player a clear view of the road ahead. And to make all that happen, I'll see you in Unity. Let's get started creating our very first Unity project. Now remember to watch me before you do this yourself. Now up first, just for some organization, I'm going to create a new folder on my desktop where I'm going to be saving my Create with Code project. So if I right click on the desktop, I'm going to select New and create a new folder. Then I'm going to rename this folder Create with Code Carl D. That way I know that this is where all my projects are going to go. So if I press enter, now I have a folder on my desktop where I'm going to be saving all of my Create with Code projects. The next thing I'm going to do is create a new empty project called Prototype 1 on the correct version of Unity through Unity Hub. However, since Unity Hub is changing all the time, we want to make sure you have the most up-to-date instructions. So I'm not going to demonstrate that in the video. Instead, I want you to very carefully follow the instructions below to create your project. So just make sure when this video is over, you follow the instructions below the video to make your project. I'm just going to skip forward when the project is already made. And here you can see my new Unity project for Prototype 1. And you can see here the Unity interface. Now, if this is your first time seeing it, it may be a little intimidating with all of the different windows and buttons. But don't worry, we'll go through it in detail very soon. So for now, this is where I'll stop and let you create your own Unity project. Make sure to follow the steps below to create a folder to save all of your Unity projects, and then create your very first Unity project through Unity Hub.
Huh. Okay, so they're really going back to basic with that stuff. I didn't notice my tuber froze there for a sec. So unlike what they said I started doing before watching, or rather because this is redundant information, like I already know this stuff. This stuff is the stuff that we'll have to actually view, but I did create the folder already that is on my desktop. I realized they had that because they want everything in this whole junior programming course to be in the same place. It's like, wait, why didn't they do it? Oh yeah, that's why. But yeah, currently we're waiting for the project to load up. So since they have the whole watch and do thing, I'm going to watch this video while we are loading the project because it takes forever. So let's keep watching.
Now that we've created our first Unity project, let's start getting our scene set up by importing the project library. Now remember, watch me before you do this yourself. In order to download our project files to get started, we'll need to use the download link in the instructions below this video. If I click on that link, it will download a zip of the starter files right onto my computer. So let's see where I saved those files. On my desktop, where I created that new Create with Code folder for my projects, you can see here I've already downloaded
the project library for prototype 1. So all I need to do is extract this folder to get the assets I'm going to use for my project. So I'm just going to right click on prototype 1, extract all, and then it's going to select a location, which in this case is the folder that I'm already working in. So I'm going to extract, and you can see that it extracted pretty quickly. And if I go into this new prototype 1 direct download folder, you can see here that I have the prototype 1 starter files, and it's of type Unity package file. So this is what I'm going to use to import into my project to get set up. If I head into Unity, I'm going to go to the Assets button on my menu, go to Import Package, and then Custom Package. Now I need to find that Unity package file that I just extracted. So I'm going to go to that Create with Code folder on my desktop, go down into the Prototype 1 Direct Download folder, and find the Prototype 1 starter files, select it, and open it. You can see that Unity prompts you with a new window asking you if you want to import all of these different files, and we're going to need all of these for our project, so I'm going to import at the bottom of the window. Now let me show you what Unity just did. So if I get started in Unity, down in the project window down here, you can see that there's an assets folder that has a course library folder and a scenes folder. So the course library folder is what was just added into our project. And if I click into this folder, you can see that there are some additional folders for some of the props and objects that are going to be in our scene when we get started. So for example, I could go to the obstacles folder, and you can see here a list of different obstacles. You can actually use this little slider at the bottom of the project window if you want to actually see what the models of those objects look like. So now you can see we have all these different props that we can use in our scene, like a rock or a barrier or a traffic cone. Now I'm going to show you what this actually looks like inside of Unity. So if I go back to my assets folder by selecting it on the left-hand side of the project window, I'm going to go into the scenes folder, and inside of my scenes folder, I have a sample scene, which is actually what's currently open right now, which has nothing inside of it. Or I can open up this prototype 1 scene by double clicking on it. And now inside of this prototype 1 scene, you can see that it pops up inside of this scene window here in the center of Unity. And if I just use my mouse while it's hovering over this scene window, right click and hold, I can actually move the camera that's in the scene view to see around this virtual world that we've created for you. So you can see here we have this long road. We have some of those mountains in the background. We have a pretty cool sky with stars in it. And so this will be the scene that we'll start building our first Unity project in. Now, since this will be our main scene, we actually don't need this sample scene anymore. So I'm just going to right click on sample scene and then delete it and delete the selected asset. So now the only thing that's in my Unity project is that prototype 1 scene. So what you're going to do is download the starter files for the project by using the link in the instructions below this video, and then you're going to extract that zipped folder that we gave you, and you can double check to make sure that inside of that folder are the prototype 1 starter files. Once you've unzipped those starter files, you're going to head back into Unity, go to the Assets button in the top menu, go to Import Package, and import a custom package. From there, you're going to find the folder where you extracted those starter files. So in my case, on my Create with Code Carl D folder on my desktop. And you're going to find the prototype 1 starter files Unity package file. So you're going to select it and then open it. You'll then be prompted with an import window. So in my case, since I already imported these assets, I don't have to worry about it, but you'll see a long list of different files, and at the bottom right of the window, you're going to click import, and that might take a few minutes. Once you've done that, you can head over to the project window down in the bottom of Unity, select the assets folder, and go into your scenes folder. You're going to double click on prototype 1 to open it inside of your project, and then you can just right click and delete the sample scene because we won't be using it. And then if you want to explore the virtual world that we've created, you can just hover your mouse over the scene view here, right click and hold the right mouse button, and then you can move your mouse to move your camera in this virtual world. So now it's your turn.
Alright, so, music back on. Probably. Froze again. Okay, so, first I moved my stuff over. I think I missed something out. Let me see, where is it? Okay, there we go. I wanted to put the folder that we had for this over in something else. So that's what I did there. And it should be okay now. Load that up. I'll put it on the display when we do that. I already extracted the file, but we'll read these steps just in case I mess anything up. Okay. Extracted it, import the assets package into your Unity project. So we want to go to our package manager. It'll take its time. Then we want to grab, where is it? Create with code. No, do I have to run that first? Oops. Okay. Import everything. I always forget that this doesn't capture those windows. It's kind of funny. Okay. I probably want to update these, so I guess I'll do that now. My Visual Studio Editor stuff was not updated, so I figure probably a good idea to update it. And since all of them use WebGL, I guess I should just grab WebGL right away. Right? I'll just prematurely get WebGL. Won't need it right away, but figure we'll probably need it eventually. Okay. Anyways, wanted to check around. I did not realize you could use this to see the asset itself. So that is nice. I didn't know you could do that. But we want to open up our sample scene, get rid of our other one, or reverse what I just said. Reverse what I just said. You don't want to do that. So, to my understanding, we're probably just going to start here, right? And then we just keep zooming, but the road is going to somehow repeat itself, right? Or at least is just going to go and then stop right away. Something like that. But we can view the scene now. We're on the road map, roadhouse, whatever. We got a road here. And now we're good. We're good with that one. Now add a vehicle into your scene. So, music stop, muted. Since this is the programming thing, like I said, I want to make sure I actually know what I'm doing. I want to make sure I know what I'm doing. So even if some of this stuff is redundant, it's probably good to listen to anyway.
So now that we've added in the starter assets for our project, we're gonna go and add a vehicle into our scene. Make sure to watch me do this before you try it yourself. And just as a heads up, from here on out in these videos, I'll be using an older version of Unity. As you can see, the icons look slightly different, but otherwise everything is gonna work pretty much the same. What I'm gonna do is in the main section of our project window, I'm going to double click on vehicles, and that'll open up that folder, and that'll show us all of the different vehicles that we can use in our scene. I like the red truck over here. I think it looks really cool. So I'm going to left click on that vehicle, drag it into our hierarchy on the left side of Unity. When I let go, you can see that our vehicle has now been added into this large area in the center called our scene view. So all of our assets in our assets folder are what we use to populate our scene with different objects like our trucks. If we wanted to add some cool environmental props, maybe some boxes or trees, mountains, whatever we want to add, that's all stored in our assets folders, and then we can drag and drop them into our hierarchy to add them to our scene. Now the hierarchy actually keeps track of all of the different objects that are currently there. So we have our camera, we have a light, we have some environment, and then we have our vehicle that we just added. Now to really see our vehicle and experience the scene view that allows us to visualize everything that's happening in our game, what you can do is hover over the scene view with your mouse. If you hold the right mouse button, right click, and then you can actually move using the W, A, S, and D keys on your keyboard. So if I press W, I can zoom in. If I press S, I actually fly backwards. If I press A, I fly to the left. If I press D, I fly to the right. So you can use all of these in tandem, and you can actually move your mouse while you're flying around, so you can see all around your scene. Now, I have a problem here. I've gotten myself lost. I actually don't know where I am. I can see these nice mountains, though. So, in your hierarchy, if you make sure that your vehicle, your truck is selected, you can see it's highlighted in blue, so you know it's selected. If you want to make sure, on the right side of Unity, you can see in your inspector, this actually shows you what the current object is selected, which is our truck. With my mouse now hovering over our scene view, if I press the F key on our keyboard, this will actually focus or frame back in our object that we have selected in our hierarchy. So that's super helpful. Another thing that we can do if we just want to get a 360-degree view, if we want to see all around this truck, we can actually hold down the Alt key on our keyboard. And then with our left click, if we drag to the left or to the right, we can actually rotate around. And what this is actually doing is it's rotating around the center point of our screen, which in this case is our vehicle, because we use our F key to focus on it. So now we can see all around our truck. And then another helpful thing that we can do is if we press the Alt key down and hold it again, we can actually use our right mouse button. And if we click and drag that, if we go to the left, we actually zoom out. And if we go to the right, we can actually zoom in. So using all of these different keys, we can navigate around our scene, focus on different objects, and take a look at them in depth. A really helpful keyboard shortcut to know is the undo action. So, for example, with my vehicle selected, if I accidentally moved that vehicle when I was just trying to navigate around the scene, I can press Ctrl Z or Command Z, and that will undo my most recent action. This is super helpful to know just in case you ever accidentally move something, or say you adjust something and you don't like the way that it's positioned in your world. You can just undo that to set it back. One thing to note is undo will only undo our most recent action. So, in order to get this vehicle back to where it started, since I actually changed this object 3 different times, I have to use Control Z or Command Z 1, 2, 3 times, and it will set it backwards. So, it's very helpful to remember the undo shortcut on your keyboard. So that way, in case you ever accidentally move something or you just don't like the way that something's positioned, you can just reset it back to what it was before. So what you're going to do is you're going to grab one of your vehicles out of the course library, whichever one you want, left click and drag it into the hierarchy. And then when your vehicle is added to the scene, get used to playing around with all of the different ways that you can navigate your scene view. With your mouse cursor hovering over the scene view, if you hold right click down, you can move your camera around as you move your cursor. If you use the different keys like W, A, S, and D, learn how to move around in the world. Make sure you get some practice in also focusing on your object in case you either get lost or you want a better view. So go into your hierarchy on the left, select your vehicle. With your cursor over the scene view, press the F key on your keyboard so that you can frame or focus in on that object. Play around with rotating around the object, so you can press the Alt key, hold it down, and then press and hold your left click on your mouse, and you can rotate it around your vehicle while it's centered in your scene. And then you can even get some practice in pressing and holding the Alt key, clicking and holding your right mouse button, and then dragging it to the left to zoom out or dragging it to the right to zoom in. So get very comfortable with moving and navigating around your scene, focusing around your vehicle, rotating around it, zooming in and out to get a closer look of it. These are very important things to know to navigate your scene. So the easier it will be to move around your scene and get comfortable with seeing all of your different objects and where they're placed, the easier it will be as you make your game. So go play around with the different navigation keys, and now it's your turn.
Okay, this is really redundant, and they seem to do an overview at the end, so I might skip. I might skip a little bit of it if it's that redundant. But anyway. We're gonna do that really quick. Got an armored tank, blue car, ban green. I like blue. So we'll add in blue. And now we got our car. Huh. I wonder if all games do things like that. Like the objective of this is when it's ramming into stuff, it's gonna shoot it over it. So it makes sense if it's using the gravity how we've seen it, that the collider would have to have the thing shoot off of it like that. Huh. Interesting. Well, Control S. We did it. Warnings. Hang on a second. Let me just... No. Let me delete the old thing. I'm curious to see. I'm getting a warning with that, so. Well, the bus doesn't seem to have a warning. I rather, I don't know if that's because it's outdated or what, but I rather it not to give me issues. You know. But okay. We got that there then. Control S. Okay. Now we stop again. So, this time I will, I'll skip stuff if it seems overly redundant, I think. We'll see how bad it is. Because we did the whole entire Essentials course, and this seems to assume you didn't do the Essentials course. So it's like reteaching some basic stuff. So, we'll see. We'll see what we got here.
We've added a vehicle to our scene. Now the next thing that we need to add is an obstacle. So we're going to choose one and place it in front of the player. Make sure to watch me before you do this yourself. Now, down in our project window where we got our vehicles, we're going to make sure that we go to the sidebar, select our course library so that we can see all of the other folders inside of our course library. And then we're going to go to the obstacles folder and double click. And you can see here we have all of these different options that we can select from. I'm going to choose this crate because our truck actually has some boxes on it, so it looks kind of similar. So this time I'm going to left click and drag our crate, but instead of going into the hierarchy, I'm going to drag it directly into our scene view, and you can see that it's actually updating live wherever my mouse is positioned. And in fact, if I drag it closer to the road, it actually snaps directly onto the road. I can even do it with the car. Look, there's a box on the car. So I'm going to release my mouse button now, and you can see our box has been positioned.
Okay. It doesn't look like I need to pay attention to this one. That seems overly redundant. And the inspector changed the XYZ location to that. We get it. One obstacle. Could just use boulder. But, I'll use a barrel. Okay. That is there. And they want you to change it to obstacle and vehicle. Did I spell vehicle right? No, I did not. I don't ever need to spell vehicle. Wait, am I spelling it wrong again already? And then icicle. I don't know why I don't just copy and paste it. That's easier. Then I don't have to worry about if I spelled it right, because if they spelled it wrong, then that's on them. Okay, we got those. Next one. This seems like it'll be redundant.
Now we've added our player, our vehicle, and our obstacle to our scene, but now we really want to get a...
I read the instructions. It's redundant. It's just telling you how to use the camera. Move the camera behind the vehicle. Okay, customize your interface layout. Okay. Well, I don't know if they mean the actual camera or not, but they just want me to do this. So we'll humor them for now. I guess this one I'll listen to for a second at least.
So we've set up our camera, so now that we have a good perspective of what our player will see, we're going to play around with the actual Unity editor itself to rearrange some of our windows and make it easier for us to navigate. So a really cool thing about Unity is you can actually reorganize all of these different little tabs that you see to clean up our project and make it a little bit more efficient for us. So in fact, for example, with our game view, if I left click on it and I drag it, it actually snaps out of the view that we're in. And I can put this wherever I really want. So I can put this underneath the scene, and then we can actually resize these windows. Or if I left click and drag the game again, I can drag it down to the bottom where our project window was and put it down there. So that's kind of cool. We can rearrange things however we want. Luckily, in Unity, we can actually just do all of these things with some preset options. So on the top right, all the way past the inspector, in the corner, you can see this little button that says default. So in fact, if I left click on that, and since I move things around, if I click on the default button again, it'll reset my entire editor experience to be back to what we had in the very beginning. And then if I click on the default option again, there's other options. So there's a 2x3, which is kind of cool. There's a 4 split. So this is kind of useful, especially if you're doing like a 2D game or something like that. There's a tall layout. And so this one puts our scene view and our game view side by side, which is kind of useful. We have a much larger view of what is happening. So I actually kind of like the tall view. So what I'm going to do is I'm going to rearrange some things a little bit. So I'm going to make our inspector just a bit smaller. So you see these lines between the windows. You can actually mouse over them. It turns into this little drag icon. And then you can click and drag our inspector. So I'll make that a bit smaller. I'm actually going to make our hierarchy and our project column a little bit smaller too. So I'll click and drag. Now our project window is kind of messy now. So what I could do is all the way at the bottom right of our project window, there's this little slider at the bottom. So this actually makes our icons larger. If I drag it to the right, if I drag it all the way to the left, it actually makes it smaller. So then I can like double click on these instead, and then it'll just create list views of what I can see. But I don't get those cool little previews of our little assets, unfortunately. And then it's still kind of it's still kind of narrow. If I had longer names, it'd be really hard to see. So in fact, I'm just going to turn this into one column entirely instead of having these two small columns. So in my project window, all the way on the right side, there's this tiny drop down. And if you're using a new version of Unity, you'll see 3 dots in a vertical line. So if I click on that, you can see there's a 2 column layout or there's a 1 column layout. So if I click on the 1 column, now it gets rid of my folder previews for what I can see inside my vehicles folder. So now instead, I just have to click on these little drop down arrows and then it shows me all of the different assets that I can use. Same thing with the obstacles. The nice thing too is it makes it a little bit easier if I collapse the vehicles folder and then I can even collapse my course library. Now it like looks really clean, which is helpful. And then the last thing that I'm going to do is I'm going to left click and drag the game window, and I'm actually going to drag it to the bottom of our view, and it pops like that. Now, one thing that might happen is, for example, if you actually drag it out of a space where there's anywhere it could snap to, it'll actually pop out like this, which can be helpful sometimes, but not entirely ideal. So you can actually just click on that tab again, drag it back, and then snap it in place. And now if we make this a bit larger, cool. Now we have a really good view of our game and our scene at the same time. So this is what we as the creator see versus what our player will see when they play the game. And then if we want to actually save this all the way on the right side back to where we set our layouts, if you click on that, at the bottom of the options is actually a save layout. So if I click on save layout, I can rename. So I'll call this my.
Okay, that one isn't terrible to know, I guess, but I feel like the layout is not like bad to me. at default. I don't feel like I want to change this layout. I've been using it already. Like, the most I would do is like shift this over a little bit, maybe. Maybe do that. I don't know how much I would actually wanna move over though. Like maybe I would shove this here and do this kind of thing. But I don't know. I don't know. I feel like at the same time I would want it still over here just because I'm used to it. I like to have the bigger room to work in when you're actually adding stuff together. But I don't really have a reason to edit anything else in right now. Set up stuff, new concepts, next lesson. Okay. I'm not gonna bother watching that video because it's just explaining what we just went over. And that's fine. Sure, you're an engaging instructor. Now let's get into the actual meat and potatoes of it. Yeah, I don't know if that'll always cover. Like that covered all the stuff that we already knew. That was most of that. And we were setting up what they want us to do for this first part. In this lesson, you'll make your driving simulator come alive. First, you'll write your very first lines of code in C#, changing the vehicle's position, allowing it to move forward. See, this is the stuff that we want. Next, you'll add physics components to your objects, allowing them to collide with one another. It looks like the vehicles already have it, though, which is kind of lame. I thought they would start from, like, the beginning, but... yeah. Lastly, you will learn how to duplicate objects in the hierarchy and position them along the road. We already know how to duplicate objects, so that's not that big of a deal. You'll have a moving vehicle with its own C# script and a road full of objects, all of which may collide with each other using physics components. Okay, so that's the overview. That's not a big deal. Write and apply your first script. Since this is the scripting, I guess I probably should look at the overview video. But I'm going to take a quick little break just to refill my water, and I will be right back. I will turn this back on really quick. Alright, I'm back. Oh. The stoofs. All of the stoofs. We have many stoofs to think about. Okay. Let's go. Let's go over it.
We've positioned the vehicle at the start of the road with an obstacle directly in its path. Well, last I checked, this wasn't a parking simulator, it's a driving simulator. So we're going to give this vehicle a little gas. And by the end of this lesson, the vehicle will drive down the road, crashing through the obstacles in its way. In Unity, all of the game objects in your scene are made up of components. And it's these components that determine how your game objects will look and behave in the scene. So if you want a game object to behave differently, you just need to change its components. Let's take our vehicle, for example. Right now, it doesn't have a lot of components. It just sits there doing nothing. In fact, it doesn't even obey the laws of gravity. If you raise it up in the air, it would just float there like a vehicle-shaped cloud. But if you add a particular component that tells it to obey gravity, it'll fall. What we need, though, is a custom component that will make this vehicle drive down the road. So, we are going to create that component by programming it from scratch in a new C# script. After we write the code that will move a game object forward, we'll apply that script component to our vehicle, and our vehicle will move forward. As you'll quickly find out, programming is very powerful. Just a single line of code will make that vehicle fly down the road. So to make all that happen, I'll see you in Unity.
Oh, okay. Well, I mean, this is the juicy stuff. I want to learn how to make thing move forward in general. I mean, if it can move back and words and stuff on all that, that would be nice too. Anyway.
Now watch and pay attention before you do this yourself. We have our layout set up nicely here in Unity, so everything is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window and then make sure you right-click on the Assets folder. And then you're going to go to the Create button, and we're going to create a new folder. We're going to name this folder Scripts, because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized, so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library, or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder, so we right-click over our scripts folder, and we create a C# script. Now we're going to name this script Player Controller, capital P, Player, capital C, no spaces, Controller. Now, when we press Enter, Unity will automatically create this script for us, and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C, and why are there no spaces? Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right click on it and I click create C# script, and I don't know what to name this script for now, so I'm just going to call it test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention so that way it's easier if other people have to jump into your projects. So I'm going to just right click on obstacle fly, and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector. And so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left-clicking and dragging onto our inspector if the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this gear icon next to it, and we can actually remove that component. Or if I wanted to add a component another way, I could also click the Add Component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name, so we have that player controller, added it there, but we don't want it on our obstacle at all, so we're just going to click on the gear, remove that specific component, and we're good to go. So what you're going to do is you're going to right-click on your Assets folder, create a new folder, name that folder Scripts, so that way we can see where all of our scripts in our game are being managed and organized. On the Scripts folder, you're going to right-click directly onto it and create a C# script, which you will name Player Controller, capital P, no space, capital C. And then you're going to add the player controller script either by left-clicking and dragging it and dropping it onto our vehicle, or if you select the vehicle by clicking on it, you'll see it pop open in the inspector. You can left-click and drag the player controller into.
Huh. Alright. I didn't know some of that with the UI stuff. That's a little nice. Some info is like, yeah, I already know that, but other parts there were, oh, I didn't know that. That's nice. Yeah. We want to create folder. Where is the folder? Who has the pencil? The folder's at the top, and I'm wondering where it is. Scripts. Okay, script folder is there. I'm gonna click on it. C# script. Player. Controller. And then we can grab the vehicle. You can just drag and drop it over here. Okay. And now it is there. Their controller script is now there. And that was all we needed to do for that one. Now we need to add a comment in the update method. So let's stop this and I'll throw it over to the video again.
We've created a scripts folder and we've created our first C# script and we've applied it to our vehicle as a component. And now we're actually going to get familiar with our script and the structure of it before we write any of our code inside of it. So make sure that in your assets folder you have it expanded, and then you open up your scripts folder by expanding it. And then if you double click on the player controller script, now you can see that my script has opened up in my IDE, which stands for an Integrated Development Environment. And basically, an IDE enables us to actually interact with our code and write lines of code and text inside of it. So you can actually see there's words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write an essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger. It's just a little hard to see. So on the bottom left, I have this little zoom option. So I'll set this to 200. It's pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use some different colors for words because it helps make it easier for me to see. So you can change those settings on your own, or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you will download Visual Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand. With our script itself, our player controller, you can see the name that we made before, and in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called MonoBehavior. And MonoBehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from MonoBehavior. And that's very helpful because in MonoBehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement, and here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call the start method. Versus the update method, another method from MonoBehavior, And update is called once per frame. So this is actually constantly checking in your game for different calculations it should make or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here you can see, so these two forward slash marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the purpose of a person to understand what they're reading inside of a method, versus the methods are actually the pieces of information that your computer needs to run certain tasks. So now, in our update method, we're going to write our very own comment. So make sure that you have your text selection inside of the update method. And then if you write // 2 forward slash marks, we can say we'll move the vehicle forward. And so now this is where we're going to write our line of code to move the vehicle forward. But for now, we're just going to make a note for ourselves that this is where we're going to do it. So what you're going to do is you're going to double click on your player controller script, and then your player controller script should open in the...
Okay, this part I actually know already because I've done it before when I was doing tabletop simulator stuff. So I'll get this down. Double click the script, and then we'll do our backdash move the vehicle forward. We're going to put it in the update section. Move the vehicle forward. Control S. We move on. Give the vehicle forward motion. I was taking a few little notes also on my Word document. I can't really show it right now because I have too many other windows open here. I got the lessons, I got Unity itself, and I got the script editor. Whole thing's gotten all the space taken up.
We've opened up our player controller script, and so now we can see all of this code that's inside of this script. And so we'll actually write our own line of code so that we can make the vehicle move forward from our little note we made for ourselves before. Make sure you pay attention before you do this. So what we're going to do is we're going to write our very first line of code here in our update method. So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're going to do is we're going to program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application or if you're going to make a website, there are other languages that you can use to create those different kinds of applications. But for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector on the right side, as I'm moving this blue arrow in our transform component, you can see that the Z is actually updating. And so that gives us a really good hint of what we're trying to accomplish. So if you remember, our transform component was the thing that was updating as we moved that vehicle in the scene. In fact, we can actually use the transform component directly. So if I just type in transform, and in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class that has even more methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicle's transform, what we actually want to do is we want to move that vehicle in that Z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. And so you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does, it is actually suggests different things that I can do and can autocomplete certain statements that I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector3 translation. So this is a parameter. This is a piece of information that I tell the computer to use to be able to do the thing that I want it to do. Now, I don't necessarily know what a vector3 is right now. So let's see if there's other options. You can see there's 6 total options. And this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is I don't want my vehicle to move in the X direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction, so I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon. And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we wanted to happen. Let's see. Get out of play mode. What did I do wrong? So let me just player controller. Oh, I forgot to save. So you can see in our project window, I selected our player controller script and it looks exactly like how we left it when we first opened it. There was no information inside of it. But as you can see in our script here, we've added 2 lines in here. We've added a comment and we've added this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes. It's speeding all the way off the runway. And it's flying off into space. Maybe it is a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're going to do is in your player controller script, underneath your update method, inside of your update method, underneath the comment, you're going to write transform.translate, and then you're going to use an open parentheses, type a 0, comma 0, comma 1, close parentheses, and then semicolon. Now it's your turn. So dot, the position, we want to use a method. In this case, it's suggesting different things I can do a piece of information that I tell the computer. Necessarily know what a vector 3 is right now. So let's see if there's other options. You can see there's 6 total options, and this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is I don't want my vehicle to move in the or a spaceship, so that's also 0. Parameters to our method, and we have that closed parentheses. So what I change with auto do a task, we need to translate.
I wanted to see what he said parameters were again. I couldn't find it. Let me just look more.
Property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does it is
I
actually
think it says it here,
suggests different
but I
things that I
forget.
can do and can autocomplete
I just
certain
wanted this for the
statements that
quiz.
I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector 3 translation. So this is a parameter. This is a piece of information.
I kept thinking I spelled parameter wrong. I don't know why.
This is a piece of information that I tell the computer to use to be able to do the thing that I wanted.
Okay, I wanted to make sure I got that info on here. So anyways, we want to make the transform dot translate. Right? It's dot, right? Yeah. And then 0, 1, 0, 0. Okay, so on our scripting, we want to lowercase transform, period, capital T for translate, and then parentheses for the parameter. And we want to do our 0, 0, 1. And then semicolon. We want to save that. And then we want to go over to our video gamer, or game guru. Want to play, because the script is already applied to the vehicle. And it zooms. Boy, that goes a lot faster than what the guy was showing. That real be zooming. That zoom good. Okay then. So now we can move on to the next part. We'll get back into this. Use vector 3 to move forward. So they were just mentioning the vector 3 thing, so let's hear about this. I'm gonna keep writing down info too. I have a new section in my notes that's called programming, and in this section I've been using for lingo. So I'm highlighting certain words that seem important and then writing like the definition that they go over. So yeah, I figure that'll be good for the test, the quiz. Maybe. We'll see.
Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So, with our player controller script open in our IDE, my IDE does some really useful things to make my life a lot easier. So, one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now, you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate, and if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector3 translation. Now, in order to get a vector3, I can actually just type vector3. And here, now, you can actually see we actually have a suggestion as to what a vector3 is, which is super helpful. So my IDE tells me that a vector3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand, because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand, in this case, the 0, 0, 1. So if we remove now our previous line of code, now we'll just make sure that we save. Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 0, 0, 1 to this vector3 forward. And when I press play, our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 0, 0, 1 to vector3 dot forward. Now it's your turn.
I mean, I know why they did it. That seems kind of silly. Make me do the other thing first. Jerks. Okay, so let's write that in here. We have transform, translate. But instead, we want to change this to vector 3. Oh wait, I don't need a comma, right? Oops. Oh yeah, it's full stop. Right. I have to remember that. Full stop. Forward. And then we save. Okay, so we did that. Now we got our custom vehicle speed.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame, but depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying. And for a computer, you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol. Because actually, if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening, who knows, we can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So cool, now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time.delta time times 20, comma 0 times time.delta time times 20 times 1 times time.delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20, so now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the Z value changing, and if you used a stopwatch, I'm sure you could see that it probably moves just about 20 times every second. So, now it's your turn.
Okay, I wanted to take notes on that also. So, apologies if I take a little longer on some of the parts. So all we're doing for this now is times, oops, delta time times 20. We save that, go over to here, and we play. Car is zooming away at a pretty normal speed. Okay, so now we have to add rigid body. We do know how to do this, so we might skip over it, but we'll have to see what they want us to do with it. But I'm gonna take another break real quick. I think I've been going through my water too quick. But yeah, I'll be right back. Alright. Alright. Let's do more things. As in, let's watch more videos of someone else doing things. Or at least let me select the vehicle. Add component, select rigid body, select obstacle, then the hierarchy could add component. And test again. Okay, so I don't know what they mean by the kilogram part, so I guess I'll have to watch some of it.
Our vehicle now speeds along at a normal rate instead of incredibly fast or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our component system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body, which is a physics concept, and in this case allows us to interact with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier. We can use gravity or we cannot use gravity. So there's all of these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go and with our obstacle selected in the inspector, we click Add Component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics, they both have mass, they both use gravity. So that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, you can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example, on our obstacle, if we turn off our mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make our little driving game simulation a bit more realistic, we're going to increase the masses of these two objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20 kilograms or so. And then the mass of our vehicles, I don't know, maybe something like 1,000. So now this has even more weight behind it. So when it hits that box, we should see a slightly different effect happen. Yep, see? So took much longer for that crate to fly over the vehicle because it was much heavier. So, fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road, using rigid bodies to be able to create physics on our objects, so that way our obstacle actually has weight, our vehicle has weight, and we're using gravity, so it's actually being pushed down into the ground at all times. So, what you're going to do is on your vehicle, you're going to select it in your hierarchy, and you're going to go into the inspector on the right side, click Add Component, and you're going to add a rigid body. And then the same thing you'll do with your obstacle, select it in the hierarchy, go to the inspector, click Add Component, and then make sure you either search for or select the rigid body component out of the list. So you can do that either by going to Add Component, going to Physics, and then you can see all of the different options like the rigid body, or you can just type in rigid body, and there it is. Super easy. Now it's your turn.
Okay. Well, I didn't realize that this all measures everything in kilograms, so I guess that's helpful. So, let's do this stuff then. So we don't need to change our scripting right now for this. We just, yeah. Go into our vehicle stuff. Oh yeah, I was wondering I couldn't interact with this. It's because I'm not in the scene. But it's like they were saying, I don't need all this stuff thrown out there right now. We'll add a rigid body. This is the mass of the vehicle right now. Let's see. What is bus in about 11,000 kilograms? Let's try and be realistic, right? There. Oh. I just can't use a comma. I don't know why I thought I needed to. Okay, and then this has a metal barrel. We'll say it's got something heavy in there. We'll just make it 100. Wait a second. Did I put that rigid body on? Did I just blink and it was there? Huh. Well, anyway. I mean, it functioned. Hmm. Oh. Hits it, but it doesn't exactly fly, because it does have a bit of weight to it. Probably like an oil barrel or something. That's okay. Anyway. Got a super heavy bus. It's all good. Trying to apply reality to it. Now we can duplicate and position the objects. So, does this say anything odd? Because we know how to do this part. Click and drag your obstacle to the bottom of the list in the hierarchy. Control D. Duplicate, we know that. Repeat a few times to create more obstacles. After making a few duplicates, select one in the hierarchy. Hold Control click to select multiple objects, then duplicate those. Okay. So we already have it there. So And then I could just make even more. We can just sort of put them all there. Oh no. What a catastrophe. Let's do something a little dumb. Why not, right? I wanna yeah, that should be fine. That falls off the bridge. Just for the sake of this, I want to see. I want to see. What if I like? Yeah, that messes them up. Okay. I guess I could try and make that smaller, but we won't worry about that. We got a few barrels around. Oh, here, how about we I'm gonna do something a little dumb. Do something a little dumb again. Oh, yeah. Okay. Dumb, but fun. Chum is fun. Okay, let's save that. And, I guess let's just go on. Vehicle moves down the road at a constant speed. When the vehicle collides with an object, then fly into it. C scripts, start versus update, comments, methods, pass parameters, time delta, multiply, operator, components, collider, rigid body. We'll add some code to our camera so that it follows the player as they drive along the road. Okay. That sounds good to me. I think that was all good. I understood all of that. Keep your eyes on the road. In this lesson, you'll code a new C script for your camera, which will allow it to follow the vehicle down the road and give the player a proper view of the scene. In order to do this, you'll have to use a very important concept in programming, variables. Okay, so now we're getting into the juicy stuff, the juice.
We've successfully programmed the vehicle to drive down the road, colliding with obstacles as it goes. But the poor player is left behind, missing all the action. So by the end of this lesson, the camera will follow the vehicle down the road, giving the player a front row seat to the wreckage. In order to keep the camera behind the vehicle, we have to understand a fundamental new programming concept: variables. A variable is just a piece of information that can vary or change. And variables are critical for what we're trying to do here. Since the vehicle's position will always be changing or varying, we need a variable to track that position. You couldn't set the camera's position to a fixed number like 5, 10, or 100. It wouldn't be able to move with the car. So we'll make a new variable for the vehicle's position, set the camera's position based on that variable, and just like that, your camera will be able to stay right on your vehicle's tail. To make all that happen, I'll see you in Unity.
Our vehicle now can drive all the way down the road. We have all these obstacles that they can collide with. It has a whole bunch of physics applied to it, but our vehicle still moves a little bit fast, so we want to be able to change it, and we also want to be able to see it. To do that, we're going to use something called a variable. So, in our player controller script, right underneath this first curly brace, underneath player controller, we're going to create a new line by pressing Enter, and then on that new line, we're going to create our very first variable. So we're actually going to use this variable to be able to change this number here. So usually in code, it's pretty bad, especially when you have what's called a hard-coded number, because that means that if you ever need to change it, say we reuse speed for some reason ever again, we'd have to keep changing the number 20, versus we could just change the number in our variable. So what we're going to do is we're going to use the word float. Now, float is a keyword that helps the computer know that we're creating a number with decimals in it. And then we're actually going to say what the name of this variable is. So we can call it speed. And we're going to use the equal sign here. Now, it's very important. The equal sign to your code is very different than an equal sign when you're doing math in the real world. So this actually will assign our speed variable a value. So our speed will be set to whatever number we put next. and it will store that number whenever we need it. So because we are using decimals, we'll type a 5.0, so this is a decimal, and then we add a semicolon at the end, so that way we know we're at the end of this line. We are done with our statement. Now you can see that our IDE is pretty mad at us right now. There's this red underline, and it says that it doesn't understand what this 5.0 means. So actually what we need to do is we need to tell our program that this is a float, and so we add the F at the end. So now, as our computer tries to understand this line of code, now our computer knows that 5.0 is supposed to be a float specifically, so we add that F at the end. So now we have our speed variable. It's always carrying the number 5. If we ever need to, we can change it to be 10 or 20, whatever we want it to be. And so where we have our 20, in our update method, where we're transform.translating our object, we'll take out our 20 and just put speed. So now our code knows that we are multiplying by the value 5, even though we're using the word speed. So that's very helpful. So now, if we test our game, our vehicle should be moving a little slower. Not bad, so it's moving about 5 meters a second, and now it's just pushing those boxes along. Now, we want to actually be able to see this speed variable in Unity. So right now, our speed variable is a variable that belongs to this entire class. It's what we call a member variable. And right now, it can only be seen inside of methods inside of this class, and it can't be used outside of this class. Now, we can actually use the word private to denote the level of access that somebody has with our speed variable. The private keyword is what's called an access modifier. In fact, the public keyword is also an access modifier. So private can only be accessed within this class. In fact, this start and update method are both inherently private, so you don't actually need to type the word private. Versus the word public means that you can access, you can see, you can use this class in other places. So in fact, we want to be able to see and interact with our speed variable. So we will actually make this a public variable. So now that we've used the public keyword to modify its access, we should be able to see it in Unity. Now, a cool thing that happens when we go into Unity, if we click on our vehicle in the hierarchy, in the inspector, underneath the player controller script, you can actually see our speed variable now because it's public. And we can actually change the values however we want just by typing in any number. So I'll set this to 15, and then we'll press play. And you should see the car zip down the road. And a cool thing I can do, if I left click and drag on the speed variable on the word itself, if I drag it to the left, it actually brings it negative. So you can see it racing down the runway. Then if I bring it up, it goes up. And so this is a cool way to see exactly how fast you really want this vehicle to go. And then 5's kind of a good speed. Let's make it to like 11 or so, 12, cool. Now when we stop playing, our speed variable reset to 15. Well, if you remember, when we enter play mode, if we edit values, it'll reset those values when we exit to the way that it started when we were in our scene. So it actually set it back to 15. So we'll just bring this to like 10 for now, and then we'll save. A fun little tip for when you're programming, something that people commonly say whenever they create their variable, but then also assign it a value at the same time. This is called initializing a variable. And so we initialize the speed variable to be at 5.0 for its speed. So what you're going to do is you're going to create your very first variable so we can store the speed that we want our vehicle to move. Make sure that you use the keyword public, so that way we can see this variable outside of this class and use it. Use the keyword float, that way we know that our speed variable is a number that uses decimals. We can choose what we want to name our variable, so we'll name it speed, and then we use the equal sign
to assign or to set our speed to be 5, and then make sure if you use the .0 just to add an F at the end, so that way our program knows that this is a decimal number. And then in your update method, change the 20 to speed and test your game. And then while your game's playing, if you select the vehicle and then you go into play mode, you can actually left click on the speed under the player controller and drag it, and you can change the numbers by scrolling side to side. Now it's your turn.
Learning. Very loud learning. Anyways, let's do some of this. So, we're gonna edit our player control script a bit more here. We're gonna make a public class. We're gonna make a float. Its speed will equal whatever we feel like. So let's have it speed equals. Oh yeah, and right float. Speed equal. And then we'll have it equal, I mean, it doesn't really matter right now. I don't think it's going that fast. I'll just say it's 18.0. How about that? And then we just semicolon there, right? Well, no, we need to add in the F. And then semicolon. And then we can change this to speed. It's like Baba is you. So then in this, when you click on the vehicle, you should look under the script. And it has speed there now. And we got speed right here. And then we go in. We can make it slow down, make it reverse, and make it speed back up, boost it, and bring it back, destroy all the barrels again, and then speed it back up. And the speed will move based on the weight too, it would seem. So that's interesting. I wonder if the way to think of it is miles per hour, or if it would be kilometers per hour. I mean, I think it would be kilometers since... Well, yeah, that's what they measure speed in, right? I forget. Anyway, we did that. So that wasn't that bad. Now we can go on to create a new script for the camera. This will be the interesting part, moving the camera, and this will actually be a different thing, it seems. Create a new script, follow the follow player, touch with the camera, add a public game object player to the top of the script. Select main camera, then drag the player object. Okay, so let's see how this goes.
We've added a variable to our vehicle. So if you select the vehicle in the inspector, you can see that speed variable under the script. Now when we press play, we can actually click on that speed variable, drag it, and we can control the speed. So we've got some good control, but our camera is still locked in the same place. So we want to make it so we can actually follow the player as they move back and forth. To do that, we'll create a new script. So underneath your assets folder in your project window, if you go down to scripts, right-click on scripts, create a new C# script. We're going to name this script follow player because this will attach to our main camera And the behavior will be that the camera will follow the player. Make sure you name it correctly with the capital F and the capital P with no spaces. And then we're going to left click on follow player and drag it onto our main camera. Now, if we click on our main camera in our hierarchy, you can see the follow player script has been applied as a component. So now we're going to open our follow player script by double clicking on it. So now our script has opened in our IDE. And what we're going to do is we're going to use public variables, but in a very different way this time. So what we can do is we can actually get a public variable. And what we're going to do is we're actually going to use a class or a type, in this case, a game object. And so, like I said before, things like our obstacle or our vehicle are game objects in our project. And so actually, we can get references directly to our different game objects like our player. If we check in Unity, you can see now on our follow player script, it's added this line of code. If we select our main camera in the hierarchy, you can see that the follow player script has this player variable, and it's looking for a reference to a game object now. And so in fact, we can actually left click and drag our vehicle from our hierarchy into that box, and now our player variable is tied to our vehicle. This is one way that you can get a reference to an object in the scene for another object to use. In this case, our main camera to use the vehicle. So variables can be used in really powerful ways, not just to store numbers, but to store references to other things that already exist in our game. Now what we're going to do is we can do a really interesting thing where we can actually get the transform. So this gets us the current transform component of the game object that this script is applied to, in this case, our camera. So we get our camera's transform, and we can actually just get its position overall. And so this will give us the X, the Y, and the Z of where our camera currently is. Now, we're going to use that equal sign, that assignment operator. We are going to set our camera's position. Now that we have a reference to our player, we can actually use player. The player also has a transform component, and we can actually get that position from the player's transform component. And then if we semicolon to end our statement here and make sure we save, so now our camera's position will be set to the player's current position. So now, if I press play and you watch in the scene view, watch our camera and our vehicle, our camera should be set to the position of our vehicle. There you go. Kind of works. It's underneath the car, which is close enough to what we want for now, so we can watch it as it drives down the road, runs into the different boxes. Cool little perspective. So what you're going to do is, in Unity, make sure you go to your project window, right-click on scripts. You're going to create a new script, a C# script. You're going to name it follow player, capital F, no space, capital P. And then you can left-click and drag it onto your main camera, or just add it as a component using that little handy button in our inspector for the main camera. You're then going to open up the follow player script by double-clicking on it. In our follow player script, you're then going to create a new variable. This time it will also be public, but this time it'll be a game object variable. So that will be the type of variable that we're creating, and we're going to call it player. So that'll be the name. And then in our update method, add this line of code. So you get the camera's current transform position, and you're going to set that to the current position of our player's transform component. And then last but not least, a really easy step to forget is make sure you select your main camera in the hierarchy. In the inspector, you can see on the follow player script, there's a player variable that has no game object attached. So you're going to make sure you left click on the vehicle in your hierarchy and drag it into that box.
Okay, well, That is, interesting. I'm surprised they don't just tell you how to position the camera better right away, but what you gonna do? So, public. Then, game object. Wait. Oh. Wait. Semicolon. And then we want... well, and then if I just save it... you can see the player thing there. You can grab our vehicle, throw it on there. Okay. And we want it to track it by transforming the position, player position. Oops. Transform. Position. Transform. Position. And then semicolon. And now that we saved that, we hit play, it should show the under view that we don't want. Okay. Add an offset to the camera position. Oh good, they do this in this. I wasn't reading ahead, I was looking down at the step into driver's seat thing and not this. Anyway, let's watch.
Our camera is now positioned. Unfortunately, it positions underneath the vehicle, which is an interesting perspective, but not exactly what we're looking for. We actually want to create the same effect that we have in our camera here in our preview. So that way we're following behind the player instead of underneath the vehicle. So we'll change that perspective using some of our code. And then what we're going to do is where we're actually setting our camera's position to our player's position, this is actually where we're going to add to our player's position so that we can offset our camera above and behind our player. Fortunately, we already did some of this work before. So luckily, the player vehicle is at 0, 0, 0. And then what we did with our camera is we actually put it at 5 on the Y and -7 on the Z, so it went up and then it went behind our player here. So we can actually use those values to be able to reposition our camera behind the player when the game starts. So using our update method, since we're constantly keeping track of the player's position, we want to add, in this case, we just use a plus sign like you would on a calculator, and then we should add, I believe it was 0, and up 5 meters, and then back 7 meters, so -7. So that doesn't seem to work. So let's see. I believe the problem is, so in fact, our player's position is giving us a vector 3. And here, although this would make sense in our heads, this doesn't make sense to our computer at all. Our program is trying to add some statement that doesn't exist, and is trying to add it into our vector 3. So what we actually need to do is we need to add two vector 3s together. So we actually need to create a new vector 3, and we're going to use the keyword new because we're actually creating a new vector 3 instance. We're not creating a vector 3 variable that we're storing or saving. Since this is just temporary, we use new vector 3. And so now this will actually create a new vector 3 just for this line of code that'll have the values of 0 on the X, 5 in the Y, and -7 on the Z. Last but not least, we're going to add a comment to our code. So we're going to say offset the camera behind the player by adding to the player's position. Now we make sure we save. So now if we test our game, we should see that our camera is just following the vehicle. Awesome. So now we have a much better view of where we're driving and where we're going. So what you're going to do is in your camera's position, where you set it to be the player's position, you're just going to add a new vector 3 with the values of 0, 5, and -7. Now it's your turn.
Oh. Hmm. Yep. Always accidentally clicking things I don't want to. Okay. Huh. Well, that's interesting. I can see now in my head like why math is more important for a lot of this stuff. So if I just zero out the vehicle. And just this. Might look okay. I want it to have a different viewpoint. I want it to be tighter. I don't want it to be like that more. That's probably fine. But we'll just need to offset it differently then. What that does. So we're going to go into our code. We're going to add new 3. Okay. And I'll save that. Say that is done and test play. The type or namespace, name vector 3, cannot, did I spell it wrong or something? Oh, it was because I didn't capitalize it. That's why. I'm a dummy. Vector 3 needs to be capitalized. Yeah, it even shows that on there. I'll probably mess that up a bunch when I'm doing coding. Okay, now it is actually doing it. That's neat. Little messy. But not terrible. Make the offset into a vector 3 variable. Okay. So let's see this one now.
Now our camera is positioned perfectly behind our vehicle as it drives down the scene. What we're going to do is we're just going to clean up our code just a little bit to make it easier to understand. In our follow player script, I mentioned that it's really bad to have hard-coded values. So we're actually going to take this vector3 we've created and create a variable for it. So this one will make a private variable, so it can only be used inside of this class. So I'm just going to use the keyword private here so you can see how it's used. Very similar to a public variable. And for this, because we're making a vector3, we need to make this variable a type of vector3, and we'll call it the offset. Now we set this variable to be this value here. So in fact, we can just cut by Control or Command X with the code highlighted, and then we go to where we had the offset and we paste with Control or Command V. So now our offset vector variable is being set to that new vector that we made before with our offset position already added to it. So now in our update method, we can just add where we removed that bit of code, the word offset, and because offset is a vector3 being added onto a vector3, then we can set our position properly. Make sure you save, go back into Unity, and press play, and you should see that nothing has changed, which is exactly what we wanted to happen. So, what you're
Okay, that one wasn't that bad. I should be able to do this one pretty quick. So, I want to make a private vector3 offset. And we're having it do something so new. Okay, so this part is the one that we can just copy and paste. And then we can change this to offset. So essentially you're writing even more, and it's not actually cleaning it up. It's more or less just making it easier to read for someone else. Like, if you were the only one using this code, technically you could be a jerk, like, assuming that no one else would use your code, and just make it understandable to you only. But doing this makes it understandable to other people. And I suppose if you needed help with trying to fix things, if you had these variables and stuff set up already, then people would be able to go, oh, that's what you're doing. Understand. So, save that. So when we play, players bigger than expected. Expected. Why is it expected? Oh. I'm dumb. I didn't add the semicolon. Now I know what people means when they're like, wonder if the code will work. Junk. I understand. So now we got that. Now we want to smooth. Smooth make groove. We'll play it.
Okay, now that we have our camera following our vehicle properly, you might notice that there's a weird effect happening with the vehicle itself where it's kind of stuttering back and forth. And so we can make one small change to our follow player script to make our vehicle move super smoothly. Now, essentially what's happening is in our update method, our vehicle and our camera are both moving at the same time. So sometimes the vehicle might move first and then the camera might move, but other times the camera might move and then the vehicle will move, and so it creates this stuttering effect. A simple thing that we can do with our update method is change it to late update with a capital L, make sure there's no space so it's all one word. And with this late update method, essentially what it will do is update after our update method happens. So if you remember, for our vehicle, it's moving through the update method, constantly moving forward, and then late update is called, which will then move our camera after the vehicle is moved. So if I save this script using Control S or Command S on a Mac, head back over to Unity and then test out our script to see if it works, we'll press play, and you can see now that the vehicle is moving much smoother because of that late update method, where the vehicle moves first and then late update happens, making the camera move to follow the vehicle.
Okay, well, I did it. Let us see. Yeah, I mean, the load-in jitter is pretty much the most that I notice. I don't see anything weird now. Seems like it's all fine. Seems like we're all good. So, next one. Edit the play mode tint color. Does that matter? We'll find out.
Our camera is now well set up in our game to be behind the player, and we even added in some variables to make our code more organized. Now we're actually going to fiddle around with our Unity interface again, just like we changed the layout, but this time with a very helpful tip to know when you're playing your game. So you can see when you play the game, your interface goes from a light gray to a dark gray, which is helpful, but not entirely visible. So I'm going to show you a cool little trick that I do, so it's really easy for me to know.
We don't need that one. Let's just move on. We learned those things. It's all good. Let's keep going. Let's try and get this car actually moving with inputs. That is what I am interested in here. That's the real crunchy, tasty deal. Hit the road and gain control of the vehicle. In order to do so, we need to detect when the player is pressing the arrow keys, then accelerate and turn the vehicle based on the input. Using new methods, vectors, and variables, you will allow the vehicle to move forward, backwards, and turn left and right. Interesting. I wonder if they'll let me set it to WSD, or if I can just do that myself. I guess I'll find out.
The vehicle in our prototype is currently a very low-end, very dangerous self-driving car. You click run and the car rockets off on its own, crashing into every obstacle along the way. Not necessarily the kind of car you'd want to be a passenger in. So it's about time we let the player step into the driver's seat and take the wheel. By the end of this lesson, the player will be able to control the acceleration and direction of the vehicle using the arrow keys on the keyboard. The vehicle should move forward when the up arrow key is pressed, and backwards when the down arrow key is pressed. Luckily, Unity has an entire input system set up to help us do exactly that. When you press the up arrow, you get an input value of +1, and when you press the down arrow, you get an input value of -1. So let's say we set the vehicle speed to 10. All you have to do is multiply that speed by the input value and you're good to go. When the player presses the up arrow, it'll multiply 10 by +1, giving you +10, moving that vehicle in the positive forward direction. But if they press the down arrow, it'll multiply 10 by -1, giving you -10, moving the vehicle in the negative backward direction. Then you can basically use the same type of system to rotate the vehicle. You multiply the rotation by a positive value if they press the right arrow, turning the vehicle right, and multiply by a negative value if they press the left arrow, turning the vehicle left. Just some simple multiplication, and you've got full control of this vehicle. So to make all that happen, I'll see you in Unity.
Our vehicle drives down the scene now, and when we press play, we have this nice tint to show us that we're in play mode, and we have our camera following, but right now, we still can't really control our vehicle. It just drives all the way down the road, just running all these obstacles over, pushing them off, and then eventually it gets to the end of the road, and then it just falls straight off. That's just because there's not an end there, but we need to be able to control this vehicle's movement. So first, we need to be able to move our vehicle so that it avoids the obstacles. If we open our player controller script, we're going to need a way to control our vehicle to move left or right, so we should probably just use a variable to do that, since we know it's probably pretty bad to just use a random number. So good to think ahead in general. We're going to make this a public variable so that we can control it just like we did with the speed. It will also be a float because we'll be using decimal points. And then we're just going to call it turn, lowercase t, capital S for speed. So you can see here turn speed has different capitalization. So this is a very standard, what is called a naming convention when you're programming. So for variables, we often use lowercase letters like speed, turn speed, even transform is a variable to be able to very easily see when we're using a class or when we're using an object, when we're using methods, or when we're just using variables. Now we want to be able to move our vehicle left or right, so we'll do something similar to what we did with our transform.translate. Instead of a vector3 forward, we can actually use, there's a whole bunch of other options for vector3, so we can actually use like right. So this will move our vehicle in the right direction. Again, we're going to multiply by time.delta time, because we want to be able to update this position over time instead of once every frame. And then we multiply by that handy turn speed variable that we made before. So now in our game, if we take a look down at our game view and we select our vehicle so we can see the values, if we press play, nothing's happening. Well, that's actually because we're multiplying by a 0. So actually, if we click on turn speed and drag it to the right, it'll actually start turning right if it's positive. If we go to the left, it'll start going to the left because the value's negative. So easy way to see how we can move our vehicle left or right. Now that's great, but we'll need to be able to also control it as well. But first, what you're going to do in your player controller script, create your own turn speed variable. We'll make it public so we can play around with it in the editor. Make it a float because it will be a decimal value. And then in your update method, we're going to add another transform. This time we're translating with vector3 right. So we're using our right vector. And then we multiply it by time so that way it updates over time instead of
Okay. The review stuff, like I said, not gonna worry too much about it. But I want to make a public float and turn speed. Then we want to make a transform translate the vector3. We're doing to the right. And we want to multiply it by time. Delta time. And multiply it by turn speed. And then we end with the semicolon. And save. Okay. And then in Unity, go to the vehicle, look at the player control, have turn speed, turn on the game, and we can manipulate the turn speed. The bus crashes, flies off. Everyone is terrible. But let's go on to moving left and right more normally.
Our player can now drive down the road, and we can change the speed of its movement. We can even change the speed of its turn. However, if our player is actually playing the game, we don't want to be able to fly off the road, for one, but also, if our player is using like a joystick or something, we can't just be dragging this variable around. We can't do this for a single player, like it's magic behind the scenes. So we're going to create some actual magic so that the player can actually control their own movement. A very helpful thing to know before we get into programming this is understanding that Unity does a lot of things that make our lives a lot easier. So, in fact, if you go to the top left under Edit, or if you're on Mac under Unity, if you go down to Project Settings and you click on that, there's all these options for project settings, but what we really care about is actually our input. So this is actually our input manager in Unity, and they've helpfully already created a way where when you do something, it's already mapped to be able to change that value. So if you left click on the drop down on axes, you can see there's different ones, like there's actually fire button, so you can actually press like the left control button to fire something, or a second option, left alt, left shift. There's a jump, which is the space bar. You can take a look at all of these different options, but what we're looking for specifically are actually these horizontal and vertical axes. And so this is actually how Unity knows if we want it to go left or if we want it to go right. Using these horizontal axes, we can actually see those values change and how they change. You can see that there's inputs for the left arrow key to go negative or the right arrow key to go positive. There's also alternative buttons for using the A key to go negative or the D key to go positive, and it's called the horizontal axis. Knowing this, we can do something really easy to be able to control the player's movement. In our player controller class, first we're going to create a public variable so we can actually watch and see what it's doing. And this will be a float again, and we'll call this horizontal input because this is actually the input that we'll be tracking on our horizontal axis, left or right. And then what we need to do is we actually need to set this variable, which we'll do inside of our code. So we'll actually do this in our update method. So we use our horizontal input, we call our variable, and then we use the equal sign. So we're going to assign this variable some value. And now if you remember that input manager, so there's actually a class and a method that we can call just for that input manager. So if we type capital INPUT. So this is our input manager. It's called input. So now that we have our input manager class, if we type dot, and then we were looking for that axis before, so we can actually use our getAxis method. So this will give us the values for when we press the left or right key on that axis, but we also need to tell it which axis we want to use. And in this case, it's asking for the name of our axis, specifically a string. Now, a string is a way for your computer or program to create a word that is literally interpreted by the computer and easily understandable for us. So, for example, if I in here actually type in a double quote, you can see it actually auto-completes a double quote for me at the end. So this is creating a string literal inside of these quotes. So it'll literally interpret anything that I put in. I could literally say hello world, which is very helpful if I'm trying to, for example, print something, or I need the program to tell me an error that's happening or something like that. Using string literals can be helpful in that sense. For this, we actually type in the word horizontal because in Unity, in our input manager, the name of our horizontal axis is just horizontal. So now we're getting the input for whenever a player presses the left or right key. And then last but not least, we need to actually go into our translate and multiply this by our horizontal input. So now if you make sure you save, we can close out of our project settings. And let's make sure we select that vehicle so we can actually see what's happening on the horizontal input. Our turn speed is set to 0, so we know that's not going to work. So we'll set it to 1 for now. And then if we press play, so we should see if we press the left arrow key, it slowly moves to the left. If we press the right key, it slowly moves to the right. And we can use the A key too if we want to use the other key. It'll move to the left. If we use our D key, it will slowly move to the right. So we know our input manager is working. You can even see the values change from -1 to +1. So that's a very handy way of understanding how your input manager works. As you press the left arrow key or the A key, horizontal input goes negative all the way to -1. Or if you press the D or the right arrow key, it goes to +1. So what you're going to do is you're going to add another public float variable called horizontal input. In your update method, you're going to call the horizontal input variable. You're going to set it to the input for our input manager. And you're going to get the axis that's horizontal so we can get those left and right arrow keys. And then last but not least, in your transform.translate, you're going to multiply the entire equation by our horizontal input. Now it's your turn.
And then we can just do the same way for the other directions, I suppose. Can I spell horizontal? We'll find out. We're making horizontal input. We're just making that in general. We want horizontal input equals input period get access want to horizontal. They use a capital horizontal and then semicolon it. Okay, and then we want to make a on here to multiply it by horizontal input. Save. And then with that saved, we have these. Yeah, turn speed. And then we want to try our inputs. Okay, so I can actually control this video game. I guess for a bus this probably makes sense. turn very slowly. Anyways, that's cool. So then we need to take control of the vehicle speed. Okay, let's do it.
Our vehicle can now move to the left or the right. Looks a little weird, but we'll fix that later. The problem is we keep moving forward, and I want to be able to control that too, just to make it a little bit more interactive. So if we take a look at our input manager again, in the top left, if you click Edit or Unity, go to Project Settings, select the Input option, and then make sure to expand the axes. In this case, I'll collapse our horizontal axis. You can see the vertical axis here with the name vertical and uses down for negative, up for positive. So we can do the same thing that we did with our horizontal input and do that with our vertical input. In our player controller script, we're going to create another variable. We'll make it public as well so we can see it. We'll make it a float because we need decimals, and we'll call this forward input to control our movement forwards or backwards. Similar to what we did with our horizontal input, we'll create a new line. We use our forward input, and we're going to set this to our input manager. .getAxis, use quotes to create a string literal, and then we use vertical. And then we will change in our translate method for moving forward. We'll just multiply by our vertical input. Our forward input, I should say. So now in Unity, if we close the project settings and then we press play, we should see hopefully our vehicle doesn't move at all. Cool. And then if I press the forward arrow, it moves forward. If I press the backwards arrow, it moves backwards. Same thing with W, moves forwards. S moves backwards. And then I can even move forwards and move to the left at the same time. I can move to the right with the arrow key. I can even go backwards. Make it really challenging for myself. Can't see the boxes. And then we still have this weird issue where our vehicle can move side to side, but we'll fix that later. But we've got player movement down. So that's really handy. Now we can give our players full control of our game. An especially cool thing to note about the input manager is that this can actually understand input from a variety of different places. So for example, if your player was using a controller, then you can actually get the input, for example, from their joysticks to know when they're moving to the left or right, or forwards or backwards. So the input manager is a very helpful way to be able to get information from the different kinds of input, whether it's a keyboard, or it's your mouse, or it's a controller, different things to make your life a little bit easier. So what you're going to do in your player controller script, create a new variable, a public float variable called forward input. In your update method, you can add a new line of code similar to our horizontal input. We'll call it forward input, and we make sure to get the axis of our vertical axis. And then in our transform.translate, where we are moving forward, we'll just multiply everything by our forward input. And then in Unity, when you press play, you can test out your movement in your vehicle.
We really are getting into the fun stuff. Okay, so I added the forward input. So now we need to add in forward input and point it towards a direction here. So if I can actually write my stuff, forward input, I want it to equal input having it get access also, and having it get the access of, let me make sure I actually spell vertical right, Vertical. Hierarchies can't move. Semicolon. Then we're going to add speed to, well, multiply the speed by our forward input. Okay. So wait. I mean, they don't change that, so I guess it's fine. Well, I did all of that. I put my semicolons in. Everything should be good. So, let's... Okay. We can move back. We can strife. Okay, I get it. You can make... You set the max speed, so it's going 18 when I'm holding the 1 all the way. If I gave a little gas, it wouldn't do it, so that's what the pressure would do. Interesting. That's very interesting. Next.
We have full control over our vehicle now. It's not just driving off down the road, but now we have some weird stuff happening. So when we press the left arrow key, we slide to the left. And if we press the right arrow key, we slide to the right. To visualize again what we're trying to do, I'm going to go into my top-down view by clicking the green Y arrow in my scene view, and now I'm very high up in the sky. If I select my vehicle in my hierarchy and I press F while my mouse is hovering over the scene, we focus back into the vehicle. Now I'm actually going to select my rotate tool. So let's see what's changing actually when we click on this circle here. If we drag it to the left, you can see in the inspector underneath transform, the Y rotation is actually the thing that's moving. So that's probably what we'll want to change in our code. In our player controller class, we already have this bit of code here where we're moving left or right. Let's see, well, if we are using our vehicle's transform, then we'll need that transform component. Now let's see, luckily, because my IDE suggests different methods that I can use. Well, there's this one method called rotate, so it'll actually rotate it at an angle. Well, let's just see what it does. So if I click on the rotate method, and then I type an open parentheses, it suggests different things. So it wants a vector 3, Eulers, an axis, and a float angle. That one seems pretty useful. Well, we know that the axis is that y-axis, that vector 3 up. So actually, vector 3 dot up. And then it wants the angle. Well, we kind of already calculate an angle here because of our turn speed. Let's just see what it does. So if we select our time all the way down to our input and our vector 3 dot right translate, if we cut that out with Control or Command X, in our rotate method, after the comma, make sure to paste the entire line of code in there. We're going to put the semicolon to close that statement, and then we just delete our translate there for vector 3 right. Now if we save, we'll see if that works, if that was what we're looking for. Now when I press play, if we watch the vehicle in our game, as I drive forward, I'm turning left and I'm turning right ever so slowly, but I'm turning, so that looks pretty good. So what we'll actually do is, if we select our vehicle in the hierarchy, we'll turn the turn speed up to like 25. We'll see what happens. We're just testing anyways. Now we'll play again. There you go. Now it looks like our car is really driving down the road. That's awesome. Look at it go. Just driving all around, avoiding all those obstacles. One very cool thing to note. So, in fact, if I actually go in my scene view, and I'm going to keep play on here just so we can kind of see what's happening. So you can see in our game, as I move forward, it always knows what direction it's moving forward. Now, we've been moving all of our objects in our scene, if we select our move tool, based on the global position of things. So we're always doing it based on 0, 0. Our Z arrow will always go positive in the Z. Same thing with our X arrow and our Y arrow. But at the top left, next to all of our tools, you'll notice this button here that says global. In fact, if we actually click on global, we can set this to local. Now, let me get a better angle so you can kind of see what's happening. So as I turn the vehicle, make sure you have the game selected. As I turn the vehicle, you can see that the Z is changing, and it's always pointing in that forward direction. But then, if I switch this toggle back to global, you can see that the Z flips back to the positive Z direction of our world. So, when you're trying to position things in your world, it's helpful to have that toggle set to global. But then when you're testing things, like if you want to make sure that your object is facing the right direction, you can toggle it to local, and then you can see which way your object is pointing while you're trying to interact with it. So that's very handy. Very helpful tip in case you ever need it. So what you're going to do is in your player controller script, down where you were transform.translating by vector3 right, you're going to create a new line of code underneath it, and we're actually going to use our rotate method on our transform component. We need the axis that we're going to rotate it around, which in this case is our up axis, and then we need the angle that we're going to turn it at, so we need to make sure that we're calculating it based on time instead of every frame. We just multiply by that turn speed, and then we multiply all of that by our horizontal input. And then when I save back in Unity, you can select your vehicle, play around with the turn speed and the speed, so that way when you're pressing play and you're testing your game out, you can see how fast you're turning and how fast you're moving.
Okay, I understand. I understand. So, we're adding in the call transform rotate vector horizontal input. Delete the line code that translates right, then test it. Add turn speed, sign, then test. Okay, so so we are adding rotate so we want up because up is Y up. I understand. But it's using it for Y up instead. You want to make a comma. I only want turn speed, I don't want time dilate. Oh, time dilates at the end. That's... There we go. So then we go into here, change turn speed to like, I'll just do the 20, I'll just do the 25 like they had, and we'll hit play. Now it looks like it's a real bus turning around. Ideally, we should probably have it turn a little slower. I'll make it 20, but it works. Okay.
Now our game looks really good. Our player has full control. We got rid of that weird turning issue we had. So now we can actually just turn instead of sliding around the road. So what we're going to do, last but not least, is we're going to clean up our entire project so that it's nice and organized. Luckily, we've done that already in our project window with all of our folders. We have our scripts and we have our assets in our library. We have our scenes, so we don't have to worry about any of those. There is one bit of cleanup here in our hierarchy. We have all of these obstacles, and that's kind of disorganized. It also will clutter up your hierarchy very quickly. So we can actually take a tip out of our environment here. So you can see actually there's 3 other objects under our environment for our road, our sky dome, and our mountains. So what we're going to do, we'll collapse our environment. If we right-click on the hierarchy window, we can scroll down to create empty. So this will actually create an empty game object in our scene that we can't see. It doesn't exist. If I click off of it, there's nothing actually there. If I click back on the game object, there you can see it. So we'll actually rename this obstacles, and I'm just going to select the name in the inspector. Rename it obstacles, press enter. So we can use empty game objects to just keep track of all of the different groups of objects in our scene. In this case, I'm going to select our first obstacle, shift click to the last obstacle, left click drag all of those into that empty game object. So now all of those game objects are nested underneath that empty object. Later, we'll be able to really use nested game objects to their full power, but at the very least, we can use nesting of game objects, so our parent empty game object can just group together all of our children game objects so that our hierarchy is nice and organized. So if I collapse this, now it looks a lot cleaner, but if I ever want to go see all of my obstacles, I can click on the arrow next to it, expand, and see all the different obstacles that are there. So that's super helpful. Now, we're going to clean up a lot of the code in our player controller script. So first, we don't need these public variables anymore. We already know the values that we want to use. So we'll make them private. That way, whatever we change inside of the inspector doesn't have a different value inside of our script here. One thing we do need to do, we never actually set turn speed, so we'll need to initialize that. So I believe we had something like 25 or so. We can always change it later if we need to. We can even add some comments, so private variables, so we know that this is where all of our private variables are. In our update method, we can also add some comments. So we can add, this is where we get player input. We can change this comment because we did make the vehicle move forward. And we can add another comment underneath. We turn the vehicle. And then we save. So that way now our code is a lot more readable, very organized. We know exactly what we were trying to do. And then if we want, we can do the same thing for our variables in our follow player class. In this case, we're going to keep our game object public because we actually gave this variable a reference in our script in Unity. So if we actually turn this to private, we won't have that reference anymore and we'd actually break our camera. So what you're going to do is in your hierarchy, if you right click inside of it, you can create an empty. So it'll create an empty game object that has no real information inside of it. Doesn't really do anything. You're going to click on it and you can right click and rename, or you can click on the name inside the inspector to rename it to obstacles. You're then going to select all of the obstacles in your scene and you can drag them into the obstacles empty game object. That way they all nest underneath, they're all stored underneath the obstacles game object. So that way it makes our hierarchy a little bit cleaner, easier to manage. Becomes very important if you ever have hundreds of different things in your scene. Organization makes it very easy to see and find what you're looking for. And then in our player controller script, we're definitely going to change all of our public variables to private because we don't need them to be public anymore. And we can add in some comments so that we know what we did. So we made some private variables for ourselves. We made a note about this is where we're getting our player input. We move the vehicle forward. We turn the vehicle. Now it's your turn.
Alright. Well, I pretty much did all that while I was watching. Like they totally want you to. But that should all be good then. And then look over here. Script stuff isn't showing. I don't see what the big deal of not having it there is, but I guess just for cleanliness, I suppose. I wanted the turning to feel like it had some weight to it. It does. It still seems like it's a little floaty, but got some weight. Okay, so we're good with that. Lesson recap just goes over what we learned, and we're good there. Clear instructions. It was fun. Plain programming. Okay, so I think I will stop here for today. So, this seems like it'll be another project, so probably a good idea to stop now. We got a car moving, got to go and do things, so that's cool. And now we'll work on a plane project, probably tomorrow, and see where we go. Maybe we'll get to the quiz thing. Spent 3 hours on that, but we watched videos, I took some notes. Take our time. It's all good. Doesn't matter how long it'll take. Just slow and steady wins the race and all that. But for anyone who dropped in, thank you for watching. Hope if anyone ends up randomly watching this stuff, that it helps them learn as I am learning at the same time. You never know. It can help people to learn along with someone else and go like, oh, this person is dumb like me. I can learn too. Or they'll go like, oh, this person's actually dumb. I feel bad for them. I already understand everything. Why are they taking so long? I don't know what you'll think. But you can think what you will. I'm gonna go to bed. So, good night. And see you next time.